Okay guys, so in previous video we saw how to write comparator class, right? That's how we do. And then we call this comparator right inside the sort method, and that's how we do sorting in collections topic when we want our customized sorting. Okay, it's done. And to actually implement this whole sorting stuff, what we did, we created a extra class, right? And then we called that reference again and we were getting sorted elements. What if we can do this in one line, right? So this was sorted employees by using this comparator, right? We have used comparator and it was implemented. What if I want the sorting again, but not the way we did here, but through by using lambdas, right? Now we know how to write lambda expressions, so let's use the same understanding here. Lambda expressions. So for which method we have to write lambda expressions? For this compare method. How come? Because that's gets called. We have written a extra class. If we go back to our classes like addition, no, this addition class. So this addition class implements calculator, and we actually implemented this method right through lambda expression. In cricket class, we have this cricket class. We implemented this thing which implements some interface. Same way, we have created a class which implements something, and we if something is implementing, we have to override its method, and we can write lambda expression for that method. If you want to check this comparator phase, hold the control and click on this, and you can see it's from Java 8. You can see it is marked with at function interfaces. This interface is quite old. It was introduced in Java 1.2 version. That means second version of Java. This interface was introduced, but later in JDK 8 they have they have enhanced it. Now this is not a normal interface. It's a function interface. So this has only one abstract method, and that abstract method is compare. So what I can do, I can just take this out, so we can take a reference. Going back to sorting tester, this gets commented, so we have to write you know what do you call lambda expression for this. So it goes, of course we don't write method names, but we have arguments, employee e1 and employee e2. Again we don't give types, so I'll call this e1 comma e2. Okay, that's done. Then arrow sign, curly brace, and closed, and put a semicolon. Okay, it's done. Now I have to give a implementation, so because it's more than one line, so definitely I need to stick with this what do you call that, curly braces. So I'll go back to this comparator, copy this content, copy it, going back to our tester file, and paste it. Okay, it's done. And let's store this reference in the type, that is comparator. So comparator, the type is employee, just call this employee id comparator, and equal sign, and error is gone. Okay, now what I can do, I can copy this line from above, pass the collection reference, and this time I will give this thing, employee id comparator. Copy and give this, and what, print the reference again, but this time this implementation will come after for with lambda expression. So let's run this code one more time to see the impact, and there it is, sorted employee using lambda expression. So it's 1 2 6 9 and 10. Yeah, if there's confusion, let's remove this line for a while. So we have only lambda expression with us. Let's close this, run this code one more time. There you go. By using lambda expressions, it's 1 2 6 9 10. Yeah, so lambda expression working fine without creating extra file or any extra Java class. Like, so we are saving lots of memory, so we can do this way. So that's how we can write lambda expressions for our function interfaces. I hope it's much clear. So in next video we will start working with some inbuilt functional interfaces, and that's mandatory. You should know what are the inbuilt functional interfaces, because right now what we did, we have created our own classes, right, custom classes. Now time for learning API classes. So stay tuned, we will see some more interesting topics. Bye bye.